Hello, this is Vladimir Luzgin. During the previous lesson, I introduced the set of complex numbers. In this lesson, we will study operations with complex numbers. Example 1. Perform the indicated operations. You have to add, subtract, multiply, and divide two complex numbers. The first complex number is 3 plus 2i, and the second is 1 plus 7i. To add these two complex numbers, just add their real parts, 3 and 1, and imaginary parts, 2 and 7. Therefore, the result would be 4 plus 9i. Similarly, you can easily subtract these two complex numbers. To subtract complex numbers, subtract their real parts, 3 and 1, and subtract their imaginary parts, 2 and 7. The result would be 2 minus 5i. Complex numbers are multiplied in exactly the same fashion as binomials. So, just FOIL the brackets. Multiply first times first, 3 times 1, first times second, 3 times 7i, second times first, 2i times 1, and second times second, 2i times 7i. 3 times 1 is 3, 3 times 7i is 21i, 2i times 1 is just 2i, and 4i times 7i is 14i squared. 21i and 2i we can combine like terms, and we will get 23i, and I squared is negative 1. Therefore, instead of 14i squared, we can write just minus 14. And 3 minus 14 gives us minus 11, and the product of the given two numbers would be minus 11 plus 23i. Now we will divide these two complex numbers. We have to divide 3 plus 2i by 1 plus 7i. In order to perform this operation, we will multiply the numerator and the denominator by the conjugate of the denominator. The conjugate of the denominator 1 plus 7i is 1 minus 7i. In the numerator, just FOIL, expand the brackets, expand and multiply 3 plus 2i by 1 minus 7i, usual way. 3 times 1, it means first times first. 3 times minus 7i minus 21i, it is first times second. Then second times first, 2i times 1 is 2i, and second times second would be plus 14, because I squared gives minus 1. In denominator, we have difference of squares. It would be 1 squared, which is 1, minus the square of 7i, it would be 49i squared. Then, in the numerator, we can combine like terms. 3 plus 14 is 17, minus 21i and plus 2i is negative 19i. Because I squared is negative 1, in the denominator we will get 1 plus 49, which is 50. And then we can write this by dividing 17 by 50 and 19 by 50. And we will write this as a complex number, 17 over 50 minus 19 over 50i. So the quotient of these two complex numbers is this complex number. Example 2. What complex number is the multiple inverse of 1 plus I? Phrase is squaring. multiple inverse. What does it mean? It means you should find complex number z, which, if we multiply it by 1 plus I, produces 1. So we have to solve this equation. 1 plus I times z equals 1. Z would be multiplicative inverse of 1 plus I. To find z, we divide 1 by 1 plus I. We have to perform this division. In order to divide 1 by 1 plus I, we multiply numerator and denominator by the conjugate of the denominator, by 1 minus I. In the numerator, we will get 1 times 1 minus I is 1 minus I. In denominator, we have formula. Sum of bases and difference of bases is difference of squares. So in denominator, we will get 1 minus I squared. Because I squared is negative 1, 1 plus 1 gives 2. Therefore, the result is 1 over 2 minus 1 over 2I. This is the multiplicative inverse of 1 plus I. If we multiply 1 plus I by 1 over 2 minus 1 over 2I, the result would be 1. Example 3. If f of x equals x cubed plus x squared plus 2x plus 6, find f of I. To find f of I, we must substitute I instead of x into this function, into this polynomial. So we will get f of I equals I cubed plus I squared plus 2I plus 6. We know that I cubed is minus I squared is negative 1. Then we combine like terms, minus 1 and 6 would be 5, and minus I plus 2I gives I. Therefore, f of I equals 5 plus I. Example 4. Simplify. Difference of two fractions, and each fraction is fraction in which numerator and denominator are complex numbers. So we have to subtract 2 plus I over 2 minus I minus 2 minus I over 2 plus I. We have to get these two fractions into common denominator. The lowest common denominator is the product of 2 minus I and 2 plus I. So this would be the denominator, the lowest common denominator of the two fractions. Therefore, the first fraction, the numerator of the first fraction, we must multiply by the denominator of the second fraction, and we will get 2 plus I squared, minus the numerator of the second fraction, we must multiply by the denominator of the first fraction, minus 2 minus I squared. Then we just expand the squares using the formula square of sum and square of difference. Using two formulas, square of sum and square of difference. So, what is square of sum? It is square of the first term, 2 squared is 4, plus twice product of the terms, it would be 4i, plus the square of the second term. If you do not know this formula, just multiply 2 plus I by 2 plus I and expand the brackets. You will get the same result. Square of difference is the square of the first term minus twice product of the terms plus the square of the second term. In the denominator, we apply the formula difference of squares. The square of 2 is 4 minus I squared. Then we can expand the brackets. But before that, let us simplify inside the brackets. I squared is negative 1, therefore 4 minus 1 gives us 3. So in the first bracket we will have 3 plus 4i, and in the second bracket again 4 minus 1 would be 3, 3 minus 4i. I squared in the denominator is negative 1, minus negative 1 would be plus 1, and then we expand the brackets. So in the numerator we will get 3 plus 4i minus 3 but plus 4i, because we should change both signs, not only just the sign before 3. We have to change both signs. So we will get here not minus 3 minus 4i, but minus 3 and plus 4i. And denominator is just 5. 3 and minus 3 cross out. 4i plus 4i would be 8i. So the answer is 8i over 5. This is the end of lesson number 2. During the next lesson we will study applications of complex numbers to quadratic equations. The lesson is finished. Thank you very much for participation. This was Vladimir Luzgin. Goodbye.